suspension, the mixing of solid into the liquid, or when solid is dispersed into the liquid, then it is called suspension. Understand? So what are the properties of suspension? Absolutely, it is a heterogeneous mixture because this category came into the heterogeneous mixtures. Particles can be seen with naked eyes. We can see visibly. Particles are visible or floating or sinking inside the solution. Suppose this is chalk, and when it is powdered down and mixed into the water, what will happen? It will remain suspended in water. We cannot see it is dissolved whole completely into the water. So this is the example of suspension. Okay. Path of light is visible. When we torch light, then it is visible, clearly visible. When we torch light, then it is clearly visible. The path of light will be seen with our eyes. Particles scatter a beam of light. This is the same. So unstable can be separated from mixtures by filtration. These are unstable mixtures. These just float inside and outside. So up down floating between and downwards, upwards. So these are unstable. They do not settle down completely, and they can be separated from mixtures. When we add chalk into the water, then it can be separated. It can be filtered out. So separated from mixtures by filtration. Show Tyndall effect. What is this Tyndall effect? Let's learn what is Tyndall effect. So let's understand what is Tyndall effect. Tyndall effect is the effect when the beam of light enters into the atmosphere through the particles into the solution is called Tyndall effect. In easy words, it is the scattering of beam of light, through the Tyndall effect. So, scattering what is scattering? A beam of light. Beam of light. Through what? Through particles, small particles. Through small particles. So, the scattering of beam of light through small particles is called Tyndall effect. Let's understand by a small example. So, this is the wall of your house, and there is a hole inside it. When the sun rises, then the beam of light came to your house and it is scattered. You have seen many times. So it is scattered down, and some small particles, air particles, dust particles can be seen out here. They can be seen moving here and there. So this is called the Tyndall effect. The beam of light is scattering. It is scattering a beam of light through small particles. This is called Tyndall effect. Now we'll learn what is colloidal solution. So let's start with the colloidal solution. What is colloidal solution? Yes, it is a solution in which one substance is mixed into another substance, or one substance is dispersed in another substance. Is called colloidal solution. And one of the substances in the solution, for example, dispersed phase. Dispersed phase is very minute, very small. They can only be seen through microscope. Such particles should be present. Then it will be called as colloidal solution. So, dispersed phases. What are dispersed phase? What is dispersed medium? So let's start, because these are the two important components of colloidal solution. So what is dispersed phase? The phase which is Solid is present in less amount and liquid is present in greater amount, that is called salt. For example, milk of magnesia and mud. When liquid is present in less amount and liquid, again second liquid, is present in greater amount, there must be some difference between these two liquids. So that's why some are in the very less amount and some are in the greater amount. So then it is called emulsion. And emulsion, for example, milk, face cream, etc. Then when gas is present in the less amount and solid is present in greater amount, then what is formed? Foam. The same foam is here when gas is present in less amount and liquids are present in greater amount. So this is also called foam when gas and solid. So foam, rubber, sponge, pumice, yeah, very nice. Sponge, very nice. So when solids are present in greater amount and solids are present in less amount. So means here also two solids are different from each other. Such as here liquids and liquids are two different phases. So then it is called solid salt. For example, colored gem stones. The stones which we wear in our hands, necklaces, such as rings and etc. So and milky glass. Milky glass is a type of glass. It is not milky. Its color is milky, so it is called milky glass. When solid is present, when liquid is present in less amount and solid is present in greater amount, then it forms gel. Yeah, here gel, etc. So jelly, cheese, butter, etc. So we have completed dispersed phase, dispersed medium types in examples. Now we'll come to the properties of colloidal solution. So let's see what are the properties of colloidal solution. So heterogeneous mixtures, the same. These come under the category of heterogeneous mixture. So these are heterogeneous mixtures, and the particle size is 10 to the power minus 9 meter to 10 to the power minus 5 meter. It means they cannot be seen by naked eyes because it is very small. They scatter a beam of light, means they show Tyndall effect, make the path visible. And when they show the Tyndall effect, when we torch a light, then what will happen? It will pass through it. We can see the passing of the light very visible, very clearly. So make the path of light visible, means they also show Tyndall effect. And who discovered Tyndall effect? This is the question to you. Who discovered Tyndall effect? Yes, it is John Tyndall. Quite stable. So he is the person who discovered the Tyndall effect and named it also after his name Tyndall. So he was the scientist John Tyndall. You have to remember this name. So it is stable, means the particles of the solution are spread all over the solution. It is stable. So it cannot be separated by filtration because of the very small sized particles. They cannot pass through filter paper or the sieve, filter sieve. Have you ever seen milk? Absolutely yes. So when you filter the milk, does it get filtered? No, it passes through separately. We cannot separate out the particles from this solution. So this was the colloidal solution, and you have bored learning so much of solutions, colloidal solution, suspension, true solution, and such much solutions. Now, if we get a mixture, how can we separate it? This is the right question. If we get a mixture, how can we separate it? So let's learn the techniques by which we can separate the mixtures. There are different techniques to separate different liquids or mixtures from each other. So let's see in the middle of the vessel or middle of the solution. So let's see. This is a vessel and it is filled with milk. Okay. Then when we apply the centrifugal force, as the name is suggesting, this force is applied in the center, whole center. So when we will apply the centrifugal force, it will move round and round, and what happens, the cream will come on the top of the milk. So in this way we can separate the cream from milk by applying centrifugal force. Such an example is very easy. Where are these centrifugal forces applied? Yes, in the washing machines. Do you see the dryer when it is moving round and round? What happens? The water comes out from the holes and it gets dried. The clothes get dried. So this is the example of centrifugal force, separating of cream from milk. Now we will learn how to separate two immiscible liquids. To separate two immiscible liquids, what we can do? We will use the separating funnel. The separating funnel will look like this cone. When cone is moved upside down, then it will become separating funnel. So it looks like this and it has a tube on the edge of it. So separating funnel, and here is the tap. So when the liquids are immersed in it, when the mixture is immersed in it, for example, when we add when we add water and oil, what happens? The water will float down. Water is denser than the oil, so water will sink and oil will float on it. So it will look like this. So this one is the oil. This is the oil, and this is water. So we can collect this water in a container. So water is collected in the container. So in this way we can separate two immiscible liquids. What is the meaning of immiscible? Yes, the substances which cannot intermix in each other, it is called immiscible liquids. So have you understand? I hope yes. So now we will learn how to separate salt from ammonium chloride. To separate salt from ammonium chloride, we have to apply the sublimation process. What is this new word sublimation? I have told you in the first chapter. So the sublimation process is involved in separating of salt and ammonium chloride. So ammonium chloride is a sublimable substance, means it gets into the vapor without converting into the liquid. So this is called the sublimation process, and ammonium chloride is the sublimable substance, so it will evaporate. It will evaporate without converting into liquid, and salt will be left behind. And then the ammonium chloride will become vapor, and when it condensates, it will get stuck or condensed on the sides of the funnel. So in this way we can say that sublimable process is involved in separation of salt and ammonium chloride. Now we will learn how to separate two miscible liquids. Means when two liquids are intermixed in each other, how can they separate it? To separate two miscible liquids, we will use the evaporation process or distillation funnel. Distillation funnel is the funnel in which one substance get evaporated and through the distillation funnel, it get converted into the another funnel. It will collect it into the another funnel. For example, when we add alcohol and water, what happens? It mixes completely. We cannot see alcohol is floating on it or water is floating on it. So these are miscible liquids. So how can we separate it? Yes, by distillation process. Distillation process is just like sublimation but little bit different. So distillation funnel is the funnel in which is located from one beaker to another, which is connected. So it is dependent on the melting point or the boiling point. Boiling point of water is 100 degrees Celsius and alcohol get converted into vapor very easily below 100 degrees Celsius. So alcohol will evaporate and get into the distillation funnel, and when it gets condensate, it will collect. The droplets of the alcohol will collect into the another beaker. So this process happens in two miscible liquids, distillation process, and by which it is happening? By distillation funnel. So how to obtain dye from blue-black ink? How to obtain dye from blue-black ink? So we will use the chromatography method to obtain dye from the blue-black ink. To separate the blue-black ink, we have to use chromatography method. What is this chromatography method? Yes. When we take a glass of water, this is water, and take a pencil, tie the paper from the tape. By using the tape, tie the paper, hang the paper inside till the spot where you have got the spot of the black or blue ink or dye. Till that spot, you have to submerge the paper. Now, after some time, after few minutes, you will observe that this ink, which is here, will move upwards, and different colors you can see. You can see if it is blue and black, then if you mix blue and black colors into it very carefully or very just into it, one after another, so you can see blue color here and black color here. So this is called the chromatography method. And this paper, we can use a tissue paper, but it is very light, so it should be of good quality. Or we can use the paper which have the holes in it. Not so much of big holes, very small holes, which are negligible to see. Such a good quality. So this is the method to separate, to obtain dye from blue-black ink. So now we will learn how to obtain gases from air. For this process, we will use the fractional distillation. Yes, it is different from distillation, but similar to distillation, because in this process, the air, the different gases have their different melting and boiling points. So the boiling points of different gases will be needed in this process, and this is called fractional distillation. It is different from distillation, that is simply distillation, but this is fractional distillation. So to obtain the gases from air, different gases like oxygen, nitrogen, hydrogen, etc. So we will use this fractional distillation process. What is this process? Yes, it is based on the when air is a mixture of many gases There are many gases which are mixed in the air. Yes, absolutely yes. So, to obtain different gases, we will use fractional distillation method, and it is based on the liquidification of different gases. For example, if we want to separate out oxygen from the air, then we have to find out what is the liquidification, means after condensating under the high pressure and greater temperature, it will liquidify. It will liquidify. It will the oxygen will become liquid. So by liquidifying the gases, we can by liquidifying the air, we can obtain different gases. For example, if we have oxygen, if we have air, and we are set to get the oxygen from this whole air, then what we will do? Yes, we will use this process, and we will first check what is the condensating point or the melting point of gas, liquid or gas oxygen. What is the liquidification? After liquidification of oxygen, it will become liquid, just like water. So we can obtain gas. We can obtain the gas oxygen. So this is the process. We can also separate out different gases, such that nitrogen, hydrogen, argon, etc. This process is really useful, but it takes much time because gases do not condensate easily. You can also check it out by in your real life. When sun is heating the earth, does the gases in the air liquidify? No. So it requires a high pressure and high temperature to condensate different gases. It cannot be happened by very little temperature, such as water. So this can be done by fractional distillation. Now, how to obtain pure copper sulfate, CuSO4, copper sulfate. How to obtain pure copper sulfate? Let's see. If we are given the solution or the mixture of copper sulfate, then crystallization process will help you out in separating of CuSO4 or copper sulfate. The mixture is given to you, and copper sulfate is just mixed in it. So what will happen? We use the method of crystallization. The copper sulfate will become crystals such as ice crystals. It's very nice to see ice crystals. So such as ice crystals, these copper sulfate will become crystals, and we can collect them and separate it out. The pure copper sulfate is obtained to us. The same process happens to the water. How to obtain pure water? From sea or from the reservoir, what happens? The same thing happens to the water. Let's see how. When the water in the reservoir is coming out, then it is carrying much of the pollution with it, or much of the impurities with it, sand, dust particles, etc., stones. So they are just settled down. They are allowed to settle down. When they settle down, then what happens? We can have the pure water. Then it is again carried into the another tank, and there are the little particles, such little particles like chalk, sand, and those particles are again allowed to settle down. You can imagine how the long process it is going. And when we are getting the pure water, then they add the chlorine. Chlorine is a metal. So chlorine is added to the water to kill the impurities, bacteria, viruses, etc. So chlorine is added to kill the bacteria, viruses, and germs, etc. And then we have the pure water, and that was the water which we drink. So you can understand how long process it is going for having the pure water. But I think this process is not needed, because this process is just for very polluted water. And who all are polluting this water? We humans. So if we stop polluting the water, then we don't have to do such a process. We can easily get the water from directly from the rivers. So don't have to conduct so much of big process. So leave that. Now we will learn about physical and chemical changes. So let's see what are the differences between physical change and chemical change. What makes them different from each other? So physical changes are reversible. Means they can be brought back into the same category as they were. So they are reversible. While chemical changes are irreversible, means if one substance is formed, then it cannot be separated out, or it cannot become the last substances from which it was made. So in physical changes, properties remain same. After converting into the second substance, the properties also remain same. Let's take the example. Suppose ice when changed into water and water when changed into ice. The properties of both remain the same. Means the ice and the water have the properties absolutely same. They have no differences and they are reversible. They can be changed and brought back into their same conditions after some time. So chemical changes, properties are changed. Properties of the chemical changes are absolutely different from the original constituents. Yes. For example, H2 means hydrogen plus oxygen gives us H2O means water. So hydrogen is an inflammable gas. It burns out. It is flammable gas. And oxygen supports combustion. Means it helps out in burning anything. But water, what is the property? Absolutely different. Water has the tendency to just escape out from the fire. So the properties are changed from the original constituents. So this is the process which is not reversible. We can by using some of the electrical methods, water is separated into hydrogen and oxygen by using electrolysis, but it is not separated out by any of the physical method such as in the physical changes. So this is a chemical change. It is chemical change. Properties are different. Irreversible change. It cannot be reversed back into hydrogen and oxygen. And if it is separated out from hydrogen and oxygen, we cannot make hydrogen and oxygen combine together to make water. We cannot make water by ourselves. Yes, it is the truth. Scientists till now have not made any of the water, hydrogen and oxygen combined together to form water. They can separate out water by using electricity, but they cannot join hydrogen and oxygen to combine and make the water. They have no techniques like that. So it is a chemical change. It is irreversible. We can break down the water, but we cannot combine together water. It is natural. So water is precious and we have to save it. Don't waste water. This is the photo. Okay. Now no new substances are formed because water and ice, no new substance, just H2O, same in the water and same in the ice. So there is no new substances formed. Now I have to ask you a question. If we cut a banana or any fruit, then it is irreversible because we cannot join them out. So is it a physical is a physical change. Why? Because properties are not different from each other. Properties in the first piece and properties in the second piece remain same. Properties remain same. Do you taste banana? First piece is very sweet, second piece is bitter, third piece is sour. Not like that. But they have same properties of bananas are there in each piece. So properties remain same. There is no different properties in each other. So it will come under physical change. Now in this chemical change, new substances are formed. New substance. For example, hydrogen plus oxygen gives us water. Absolutely different conditions. And this is a new substance because these both are gases. Hydrogen and oxygen are gases, but water is a liquid. So these new substances are formed. Now same melting point and boiling point. Water and ice have same melting point and boiling point because no new substances is formed. So properties also remain same. So there is no difference between melting and boiling point. But in chemical change, there is a difference between melting point and boiling point. Boiling point of water is 100 degrees Celsius. But when we talk about hydrogen and oxygen, it requires very high pressure and high temperature to liquidify because these are already gases. So it takes very high pressure and very high temperature to liquidify. So we can say that they have different melting point and boiling points. But in physical changes, there is the same melting point and boiling point. So there are many examples of physical change and chemical changes. You can also see in your life, burning of wood, burning of paper, etc. So these all are chemical changes and physical changes, cutting of delicious fruits, ripe fruits, sweet fruits, etc. Love fruits? Yes. So now we have come to the end of the chapter and the last topic is remaining, that is compounds and mixtures. How are they different from each other? So let's come to the difference between compounds and mixtures. So compounds are formed by elements. When elements combine together, they form compounds. But mixtures, when elements and compounds combine together, they form mixtures. Compounds have definite composition or ratio. Definite composition and ratio. But mixtures have variable composition and ratio. Variable but fixed. Now, compounds have different properties from elements. The properties which elements have, the compounds do not have. But mixtures, the same properties. The same properties which elements have and compounds have, the same property will mixture also carry. Compounds are separated by chemical properties. We cannot separate by physical method such as sublimation, filtration or evaporation such like that. But mixtures can be separated by physical methods. Now compounds have definite melting point and boiling point because they are combined in fixed ratio by mass and weight. But mixtures have different melting point and boiling point. They do not have any fixed mass or ratio. So here we have completed our whole chapter 2, is matter around us pure? I hope you have understand everything, each and everything very clearly. So thanks for watching this video. I will thank you to for watching this video, and I hope you learned this video also. If you don't learn, then go back and watch the previous videos if you have not watched. So I take goodbye from you. Bye. And if you want, you can take the screenshot of it. I am moving aside. Take the screenshot. I hope it is done. So thanks for watching this video.